Hello,
How you
can you
doing?
hear me?
Yeah, I can hear you.
Yeah, okay. So thank you for joining. Okay, so let's start our today's session.
Hmm.
Um, okay, let me share my screen. So I think you can see my screen now.
Hmm.
You know the list Blind 75.
Yeah.
There are another list called Top 150 Interview Questions. So this list cover all the topics. Okay,
Hmm.
top interview questions. So this list. Okay.
Hmm.
So if you like choose me first, I would pick some of the problems from this list.
Hmm.
Okay, and I have some custom list of problems I would provide you uh, by the sessions. Okay,
Hmm.
so let's pick some problem for today's session just to check how you are at problem solving. Okay,
Hmm.
fine. Mm, okay, let's see this problem.
Okay. Given an array of integers numbers, return the length of the longest consecutive sequence of elements.
That can be formed.
I see. Okay.
So first of all, it's a very easy problem if you can sort this array. But you must write an algorithm that runs in off n time, they told you. Okay. So how can you do it in off n?
I see. Okay. So we have to a consecutive sequence of elements in which each element is exactly one greater than the previous element. The elements do not have to be consecutive in the original array. Okay. So you get a random array and you need to work out the longest consecutive sequence.
Yeah.
Um, I see. And is it possible to get duplicates in the original array?
Yeah, yeah. Okay, let me see. Read the problem. Given an array of integers, then okay, and consequences shall mean okay, the element don't have a consequence. Okay. Okay, so they haven't told any specific yeah, there can be duplicate. You can see there are two
See. Okay.
ones.
I see. Okay. Okay, and we can only have to look at each number once because there's obviously an O of n time complexity. Okay, so if you were to, okay, can I just take a second to think about it? Sorry.
Yeah, yeah, take your time.
So my initial thoughts are something to do with obviously using a hash map and using a similar principle. So could you, for example, do something where in the twosome problem we use the hash map to look up the um, target, the target minus the number you're looking at. And I'm trying to think if we can do something similar here where we can look at if you're looping over the different numbers, if there's a number before or after that's in the hash map. And that's kind of where my initial thoughts are. I'm just trying to
Yeah.
think.
So can you please implement this? Okay. So can you please do it on your editor or like you can log in Leetcode if you want. I want you to share your screen.
Hmm. Hang on. Let me just. Is it okay if I just do it in Google Docs?
Yeah, you can do it on Google Docs.
There we go. Is it okay if I just do it in Google Docs?
Yeah, you can do it on Google Docs.
There we go. Is it okay if I just do it in Google Docs?
Yeah, you can do it on Google Docs.
There we go. Is it okay if I just do it in Google Docs?
Yeah, you can do it on Google Docs.
There we go. Is it okay if I just do it in Google Docs?
Yeah, you can do it on Google Docs.
There we go. Is it okay if I just do it in Google Docs?
Yeah, you can do it on Google Docs.
Okay. Um, so we have an array. We have an array, and we want to um find the longest consecutive, like
Yeah.
small array, I guess. And
And let's suppose your array is sorted. Okay. So now give me the solution of this problem. Your array is sorted now.
the array, if the array was already sorted,
Yeah.
um, then we would be able to loop over each element in the array, um, and
Let's suppose you have given an array,
mhm,
which is like one. Okay, so let me see for 1122. What is the 112233? So what would be the length of the longest consecutive sequence? Let me see in the problem. So given an array, random length in the okay, you can sort the array. Okay, so you can check, like you can pick the some numbers from the array. So yeah, so the length of the longest consecutive okay, tell me, like what would be the length of the longest consecutive sequence of this array?
it would be three because it would be
Yeah,
one.
one, two, three. We can pick one, then two, and then three. Okay, so yeah, solve this problem. Like write the implementation.
Yeah. So to do this, we would have to do. Mm, if we were to loop over number one here, and then we could look at the number one again, which I guess would mean you would ignore it. You would then look at the two, and then, so I'm just thinking duplicates don't really matter. So if you were to then look at two, you would see that two is one more than one. That's consecutive. Okay, so in this case, you would have like maybe like a variable called longest, uh, and you initialize it 0. I think you would be able to loop over the length of the array here,
Okay,
and um, and I think this you'd also store possibly the last number seen,
good.
which should just be none for now. So you would say um, if, or actually, you could probably start it at 1 and keep this at array of 0.
Good.
You could say if the array at I was equal to the last number seen, then it's a duplicate, and I don't think it makes a difference. I think you can just continue.
Yeah, good.
And if it wasn't, then if the array at I uh, is equal to last number seen plus 1, then
Yeah.
you could do longest. Oh, and if is less, so then okay, so you would need to keep a tally of the longest, but also your current streak maybe as well. So if
Yeah, good.
is current, then you would current would plus equal 1. Um, else, I think you would say if current, or maybe, sorry, yeah, if current, or I would say longest,
So yeah, if current
it
greater than
doesn't matter.
longest.
So current and longest,
Yeah, yeah,
and
we can do
current
it.
would equal 0.
Good.
Mm. And then I think, is there anything else? Ah, I have to update the last number seen as well. Yeah, seen equals uh, array of I.
I.
Yeah.
Good.
So I'm just checking that would work. Um, so you loop over the array. If it was the last number seen, uh, that's its duplicate. So in this case, you'd be here. You would then continue on to 2. If the array I is last number seen plus 1,
Yeah, it's
Um,
continuing increasing. So every when index is in the last item of this array, then okay. So yeah, please dry run your code. Then I will.
sorry, what did you say?
Okay, okay. So are you done with implementing this problem, or you?
I'll just trace it through and just
Yeah,
double.
yeah.
So in this case, would be here, which would then add one to the current. We then hit here, which would be duplicate. We then hit here and add one to the current, um, which
And the program never goes into the else.
yeah, uh, yeah. The
So
problem would go into the else, which I see the issue here. So
so you can do what you can improve in this code.
I think what you could do is
You can
you could either update it at every time, or you could just um,
yeah, or you can
or you could
uh
check if um,
yeah. No, no. So just
or sorry, you could do else if um, you could yeah. So you could either do if array is in plus one, else if array I is not equal to last number seen plus one, or it's the end of the array of the list, which is the length of the array. Uh,
so you are 99%
yeah,
with
yeah.
your 99% with your code. So we don't need to do anything which you write in the else if. Can you
Mhm.
please use command Z?
Yeah, yeah,
Please roll back everything you wrote.
yeah,
Okay. Okay.
yeah.
Yeah, please. Still, please. Yes, roll back. Yeah. Okay, fine. So what you're doing is like the program never goes in the else condition. That means what? We need to the longest consecutive subsequence. The calculation of longest consecutive
Yeah.
subsequence is like missed. So what you can do, copy the line and paste it after current plus equal to 1. No, no, just yeah, longest equal to max of current longest. Okay.
This one you're saying copy this to the bottom here.
No, 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 no.
Sorry, sorry.
Yeah, just copy paste in the after current plus equal to 1 in the above.
Ah, I
Yeah,
see. Okay, you
yeah.
update the longest here.
So every time you're increasing your count, you are
Yeah.
maximizing your longest variable. Okay.
Mhm. That makes sense. And then that way you can get rid of the self state. Well, no, you could
Yeah,
just
yeah, we need this, we need
All right,
this
okay, we need
because
to
when something is not greater than like the last number is not equal uh current minus 1, so then what it would do,
what we
it should go to else condition.
yeah, and we could also just put this out here, I think. Is that right?
No, no, no.
Yeah.
Yeah, we can also do
Actually,
this. Yes, we
yeah,
can
yeah,
also do
yeah.
this. Yeah,
Yeah, yeah.
or we can also do this. We after the for loop, we can just pass the longest equal to max of current longest.
Mm-hmm.
That would also work. So there is one like okay. So can you please tell me what would be the output for that given test case of for your program?
So in this case, we would first look at so we would in this case our current would be zero, our longest would be zero, and our last number seen would be one. So we'd start at one, we'd then see one again, which would just keep everything the same. We would then see two, and we'd add one to current, and also update longest, which would be one. And the last number seen would now become two. They would then see two again, and nothing would happen. We would then see three again. Um, oh, sorry, see three, and the current would increase to two, longest would increase to two, the last number seen would increase to 3. We'd then see the duplicate and we'd skip it. But in doing that, I've realized that I think the
It
current
should be
should be
initialized
1.
by 1 and longest should be also 1. Okay. So
So
you are done with your code.
yeah.
So very good. Okay, fine.
Mhm.
So yeah, this code is absolutely right. So now if the array is not sorted, then what will you do?
Yeah. So we can't sort it because the complexity needs to be O of n.
Yeah.
Um, and so yeah, we do need to um kind of think of a different way here. I guess. Okay, let me have a think. We're kind of storing like I don't know, some sort of chain or linked list and then checking if something is kind of in that chain. So for example, I don't really have the solution, but I'm thinking
Okay.
let's say if you have something like uh this, then you would like look at 2 and then you would look at 4 and kind of keep track that you of the fact that you looked at these two, and then you look at 1 and you'd kind of like somehow create a chain of saying like this now exists, if you know what I mean. Um,
Yeah, like okay.
and then you see 7. Uh, so that's kind of
So if you're 1, you are searching for 2. Is it present in the array or not, right? Like
yes.
if your last number is 1, you will be searching for 2. So
Mhm.
you have to check whether 2 is exist on the array or not. So how can I check a number exist or not in less time?
Yeah, so you would create a hash map in this case.
Yeah, very good, very good.
So I guess what you could do is you could loop over the 2. You could check, if 1 exists. Um,
Yeah,
and then
then
and then
your yeah.
if it oh sorry, loop over the 2 and check, sorry, if 3 exists. And uh, if it does, then you could add 1 to your current. Otherwise, you could um, set your hash map. Uh, well, either way, you'd add 2 to your hash map. So I think we could use that principle in this implementation in some way. Um, so let me just check if that works. So we would look at 2, say, does 3 exist? And add 1 to the current and update the longest. If 3 didn't exist, it doesn't make a difference. We'd add 2 to a hash map. We would then look at 4 um, and see if 5 existed.
So
Uh,
first of all, you have to pre-calculate something. So what you would be stored in your map that every number you
mhm,
you would you will be storing in the map.
mhm.
So for accessing any random element in map, like let's suppose I want to search 2 in the map. So what would be the time complexity then?
To search if the element is in the hash map, it would be O of 1.
Yeah, very good. So yeah, so you are there. Okay,
Mhm.
please continue.
Yeah. So yeah, the where was I? Yeah. So let's say you were here, you would check is 2 in the hash map. And if it is, then you'd add 1 to the current and update the longest. Um, and that would give you, in this case, 2 elements. So that 2 would be the longest. And you continue with this process. So I think I'm ready to change the
Yeah,
solution.
please go.
Um, so let's say you had like a hash map here, um, or maybe we'll say like scene numbers, something like this.
Please, can you please write the code in the below of the
Yeah, yeah,
previous
yeah,
one?
of course. Yeah, yeah. So let's say you have this is all your numbers seen. You could also keep track of the uh, longest streak, which would be started as 1, and then current streak, which also would be started as 1. Um, and we would also, do we need to know the last number seen? In this case, I don't think we do, because you just have all the seen numbers. So you could loop over all of the numbers again. Um, you could check if the number ahead, or if we just maybe make this a bit easier. Um, you could say if current plus 1 uh, two numbers, then okay, because the longest and current streak would maybe have to be stored at that new number, I think. I see. Okay, because I'm just thinking this idea of these counters needs to be in the hash map somehow. Um, I think. So if the current number plus 1 in C numbers, then the that number's uh I think we'd get the length, we call it length, would equal the C numbers at the current number. Sorry, let's get rid of those for now. Uh, 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 the scene numbers at the current number, which would be hmm, okay. I'm just gonna yeah, scene numbers at the current number. Um, so in this case, you would have maybe something like this. Um, then your scene numbers. I think also we have to think about duplicates here. So if current number in C numbers, then I think you could just continue here. Otherwise, you would have to put it into the hash map, um, which would equal the length. So, okay, a few things missing. We need to track the longest one, and also I just need to verify this algorithm because I'm not 100% convinced on it. So if I were to loop over all of the numbers in the array here, I'd start off by seeing 2. Um, and I would look for 3 in the hash map, and I wouldn't be able to find it. And so I just kind of add 2 to the scene of numbers. I would then look at 4 and look for 5, but I couldn't see that either. So I'd add 4 to the hash map. I then look for 1 and see 2, and so add 1 to the hash map. I'd then look at 7, trying to find 8, but it wouldn't be in the hash map. So I just add 7. And then I'd look at 9 and see if 10 was in the hash map, and it isn't, so I'd add 0. And then I'd see 0 and try and find 1 and see 1 in the hash map. Um, and I would make this 2, which is fine. I'm just trying to think if this always works depending on the order of the elements. So, sorry, are you still with me?
Yeah, yeah.
Yeah, yeah,
I'm
yeah. If
I'm not trying to like I'm
yeah,
not
yeah, yeah,
interrupting you. Okay, so
yeah,
please.
yeah, thank you. Yeah. Let's say the algorithm looked something like this. Sorry, the array looks something like this. Then my algorithm would first look at 0 and it would add it to the C numbers list like so. Then it would see 1 and add it like so, and then see 2 and add it like so. And like in this case, it wouldn't work, which is interesting. It makes me think if I need to
Okay,
check
can I give
above
you a
and below.
little hint? Can I give you?
Yeah, yeah.
Okay, let's suppose.
Hmm.
Okay, so first of all, this array is a random array, right?
Which algorithm?
Like the numbers in the array are not sorted. Okay,
Yeah.
so let's suppose you are on a random index. Let's
Hmm.
suppose 7. The value of the index is 7. Okay,
Hmm.
so for 7 to find longest consecutive sequence, what you can do? You need to check how long 7 can go upward. Like 7 can go to, is 7 can go to 8, is 7 can go to 9. Then you can keep going. Also, 7 can move downward, right? So is 7 can go to 6, is 7 can go to 5, then below. So this is how a chain is forming. Okay.
Hmm. So,
So if you found a chain, let's suppose the member of the chain is 4, 5, 6, 7, 8, 9. You
hmm
started from 7 and the chain length is 4 to 9. Okay.
hmm
That means what? In the chain, every elements are visited. So you not need no need to check for 4, no need to check for 9 as well. So that's how your optimize like complexity is reduced. So when you found 4 in the next time, do you need to check for 4 answer? Do you need to check the answer for 4? Do you got
uh,
it?
no. So what you're saying is, the stored values are in the hash map of the chain. I guess in this implementation, the issue is that I'm not checking down. I'm only checking up the chain by 1.
Yes, yeah. So you can check down,
Hmm.
and whenever you're visiting a chain, you should make it visited. So are you making it visited?
Um, no. So at the moment, do I need to update? I need to somehow update
Yeah.
all
So okay,
values in that
you
chain.
can use some other hash map, or you can make. Let's suppose the numbers are like you are storing the number in the map. Let's suppose if it is visited, that means what? Scene numbers of I equal be 1, and if it is again visited, then you can make it 2. That means what? I have visited this in this chain. So you
Mhm.
can use a single map in this array. Okay, so yeah, so I have gave you a hint. So yeah, please proceed.
I see. I kind of missed what you said there at the end about the scene numbers and how to store the hash map. But I think, are you saying something like um
You can use another map.
another
Okay,
type of map? Okay.
so
Maybe
do you understood my logic? What I have told you now?
not 100%. I didn't quite hear the bit about uh
Let's up. Okay, so please let me share my screen.
mhm.
Can you please stop sharing your screen so that I
Yeah.
can share my screen? Thank you. Okay. So one idea is, so if this array, let's see, the number in the array goes minus 10 to the power 9 and which up to 10 to the power 9, okay?
Mm-hmm.
So if, so I am giving you a solution for if the minimum number in this array is 1 and the maximum is what like let's suppose 10 to the power 6. So I don't have any issue here.
Mm-hmm.
But we can't store, like, since it is minus 10 to the power 9, so we can't iterate over minus 10 to the power 9 to 10 to the power 9. So it will give me time limit exceed, right? But I can iterate this 1 to 10 to the power 6. Okay, right? So what we can do, if the constraint given here is this, so I can do what? Uh, you have declared a scene map, right? Or dictionary.
Mm-hmm.
So first you would be iterating over the array, I in array. What you can do, scene of I equal be what? Scene of I would be 1.
Mm-hmm.
So we have done iterating. Now I will calculate my answer. So I would go, so now I would check for I from 1 to 10 to the 6 or whatever the maximum number in the array. So max of array. Okay. Then what I can do, if C9, then my uh, current plus plus counter plus plus, and if not C9, then what I can do. So can you please like share your doc link so that I can code?
Mm-hmm. Yeah, yeah, sure. Hang on.
Okay.
Share.
You can give me the Zoom chat. Okay.
Yeah, that's fine. Uh, there you go.
Thank you. Uh, so okay, fine. Uh, okay. Oh, I think I don't have any like
Uh,
editing permission.
uh,
Request edit access. Please.
Great. Let me just accept that. That should be good now.
So do you have enough time? More than an hour?
Yeah,
Okay, thank you. So I think this session is going to take more than an hour. Okay.
that's fine. Uh,
Let me refresh the page again.
yeah.
Yeah, now I can edit.
Okay.
So if the minimum number, sorry, if the minimum number in the array is, let's suppose 1, or max and maximum is like 10 to the power 5. So
Mm-hmm.
what would be the benefit of this constraint? Benefit here
I
is
remember in
what?
the array. Oh, sorry. Yeah.
We can we can iterate over, iterate from min number to max number. Okay.
Why can't we do that if it was negative? Because you said that.
Okay, let's suppose I don't have any negative number now. Okay,
Mm-hmm.
I'm giving all the like uh all possible scenarios in this problem. Okay,
Mm-hmm.
so what you can do, first I would have my have is an dictionary which will contain all the numbers I have.
Mm-hmm.
Okay, so for I in array, okay,
Mm-hmm.
so what I'm doing, have I equals what? 1. That means this is present in my array.
Mm-hmm.
So let's suppose mn mn is sorry, is minimum number in the array.
Mm-hmm.
minimum number in the array, and max is max number, okay,
Mm-hmm.
in the array. Fine. So, and array I, for this problem, my constraint is like 1 to array I is greater than 1, and array I less than what, 10 to the power 5. Okay,
Mm-hmm.
so simply what I can do now, so for I in range minimum to max plus 1, so what I can do, if have I, then what I can do, my count, sorry, count plus equal to 1, longest equal to max of longest, count, else what, else, so else my count would be what, initialized by 1 again, right?
Mm-hmm.
And yeah, so this is how I can check this, I can solve this problem in often. Okay.
See, so you kind of first iterate over every element to create the hash map.
Yeah, so I
Mhm.
have stored if it is present in the array or not.
Mhm.
Then I'm iterating if have I is, like have I means what, if have I is true, or is or equal 1 means what, this is present in my array, right? So I am increasing count by 1, then longest equal to max of longest. And if it is not present in the array, then what, my count. And since I am iterating over minimum to max, that means what, I am iterating over consecutive numbers, right?
I see. Okay. So it's actually very similar to the easy problem, but to get around the limitation of sorting, because you
Yeah,
really need to truly sort, you just need to know the top and the bottom.
yeah. So this is the okay, so this is the solution for if the minimum element is not negative and the maximum is up to 10 to the power 5 or 10 to the power 6. Okay,
Why would that not work if the minimum was
negative.
yeah.
Okay, why would not work? Let's suppose minimum is what, now, minimum equal to what, minus 1e9. Okay,
Mm-hmm.
and max equal to what, 1e9. So can you write a for loop for I in range minimum to max plus 1 now?
Um, I don't know. Maybe you can't. Yeah, I'm not sure.
So in a second, a computer can run up to 1e8, that is 10 to the power 8. So to run 10 to the power 9, it would require 10 seconds. So the time limit of maximum problems are 2 seconds. This is simple mathematics. Like we know 10 to the power 8 calculation can be done in 1 seconds, right?
Mm-hmm.
So to do one calculation, I need 1 by 10 to the power 8 seconds, right?
I see.
So
Okay.
to do 10 to the power 9 calculation, so we would be needed. So which is what, 891. So 10 seconds, right?
I see. Okay. So it's something to do with the fact that it would take a longer time.
Yeah, 10
Okay.
seconds. I'm like minimum of 10 seconds. Okay.
I see. Okay. I'll have a look up after this about that. Yeah.
So yeah, so this solution would not work for this. So above solution will not work. Okay.
Mm-hmm.
So let's do the most optimized one. Not most, maybe there's some optimized one. Let's do optimized one. Sorry.
Mm-hmm.
Okay. So array was given. Okay.
Mm-hmm.
Let's suppose 2 3 1 1 4 5. Okay.
Mm-hmm.
So first, same, the solution is similar. So I would have a map. So what I do for I in array. So what have have I equals 1. Have I once means it is present in the array, and if I is not in the map, then what I would be doing, I would break. So break to like whatever I was doing. So now I have every numbers which are present in the array. So now my array is not sorted. Like my array is whatever they given in the input. Okay. So now I would be doing again another iteration. Okay. So for I in array. So my current number is what? I'm at I, right?
Mm-hmm.
Okay. So while I plus 1 in have, that means what?
While the number above is in the hash map.
Yeah. So let's declare longest equals 0. Okay. Count equal 0. So here count would be initialized by
Yeah, initialized.
1
Yeah.
1. So what I would be doing, count plus equal to 1.
Mhm.
So what I can do again, while I minus 1 in have, count minus equal 1. So after that completion, okay, so you can ask me a question. This is an n square. So up to till now, this is an n square solution, but
Mm-hmm.
then I would be optimizing. Okay.
Mm-hmm.
So longest equal to longest max of what? Max of
The
longest
the
and then
the
count, right? So this is an n square solution.
mm-hmm.
So what I can optimize more now. Okay.
Mm-hmm.
So here I plus 1 in have means what? Have I plus 1. Okay,
Mm-hmm.
so let's do it, j equal to I plus 1, j in have, and after that j would be increased by what? 1. It was a mistake. Okay, and j would be again I minus 1, and this is my j. Oh, this is count plus 1, sorry, and this is j minus equal 1, right?
Mm-hmm.
So do you have any doubt up to till now?
Um, so obviously that's yeah the n squared solution. Uh,
Okay,
but
but
we
you don't have any issue with the logic, right?
uh no, not yet.
Okay, fine. So if j in have, okay,
Mm-hmm.
so what I will be doing every, okay, so can you please tell me what is the value of have j? Here have j equals what? Like
It
what
would
it would be what? 1, right?
yes, it would be one, yeah.
Because I have initialized by 1 every
Mm-hmm.
number, right?
Mm-hmm.
So when I'm in like I'm in the while loop, when I'm in the when I enters in the while loop, what I will be doing, I would be doing have j equal 2.
Mm-hmm.
Okay, then have j equal to what? 2,
Mm-hmm.
right? So when I'm in here, if have j equal to, do I need to go down?
Um,
No.
no. So you actually, yeah, you just have to, yeah. Okay.
So if it is 1, then I'm going below. So this
Mm-hmm.
is your optimized code.
I see. Okay. So, um, for an array, if you have j, uh, so you're going to check the j above and below and add +1 to both of those j's. That makes sense.
So let us implement this problem for you.
Mm-hmm.
Let's submit this in the online judge.
Mm-hmm.
Okay.
Do you want me to do it or are you gonna do it?
What you want?
Yeah,
You
I'll try and code up. Was it a neat code?
okay? So please share your screen and write the solution.
Yeah, okay.
I think it would be beneficial for you if you write the code.
Mm-hmm. Um, okay, so for roadmap, and then which one was it under?
This was an array problem, array and hashing.
Array hashing.
Yeah, go. Yeah, last problem. Yeah,
I see. Okay. So the thing that you started by doing was um creating a have hash map. So you go
yeah.
for num in nums if you would do if num have uh
First, you are initializing your have, right?
yeah number have
So why num have?
sorry have num equals 1. So we do
And you don't need to do the if. Okay, so
yeah, that makes sense. And this is the bit which is quite tricky, which I don't think I would have spotted. Um, so yeah, maybe we'll talk about that quickly after. But then you can um you need the I think you need the max number.
no, we don't need the max number. You can like go to my code again.
Okay.
I'm just simply iterating over the array for I in array, the last one.
I see, yeah. I see. Okay. So you then went for um nums. Uh you checked if num wait next number would equal num plus 1. Um below number equals num minus 1 if next number in
Uh,
oh yeah if next number in have
so this is a continuous task. If next number is have, then I need to check next minus one. So why it is an if?
yeah while next number in have then
Yeah, good.
you can do have of next number uh plus equals 1.
No, 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 no.
uh,
Please like think of the logic again.
mhm. Okay. So so you have all the numbers initialized as 1. You loop over each number. The next number is going to be the
Yeah.
next number, which is fine. While next number is in the hash.
Then you should uh decrease the next number minus one. Okay. So next number minus equal one. Okay. So remove the have. Remove the have. I am telling you. Like one. Okay. So you should increase your counter by one.
I see. Yeah, because we're not storing these values anymore, are we? So we can still have. Let me just think about this. But we have a counter and a max, and I think you can. Um, so I think you can do this, and then while next number in have, then you can do counter x equals 1, and then the uh, I think you need to do this again.
Good. should be increased by 1.
Uh-huh. And then you need to do the same with the below numbers.
Yeah, very good.
Um, so below number in have
So below number, if below number is not in the map, then you would be breaking the loop. Okay. So
the
yeah,
count
good.
the if one num's in nums
So count would be
a
increasing every time.
yeah yeah
Okay.
yeah because we don't need to reset count because
Because
he
I'm
yeah.
just calculating the length of the chain. Okay.
Mm-hmm. So
Classical one.
minus equal, no?
Um, yeah.
Plus equal here, yeah. And then you
After
here
that,
you need to check longest. Uh, uh,
so longest, very good. So now it is an n square solution, right?
yeah, this is the n squared solution.
So how what more you can improve here so that every number shouldn't be checking again and again.
Mm-hmm.
So if a number is visited, you shouldn't visit the same number again because that number is was contributed to the chain, the previous chain. So I shouldn't check any of the member which was visited in the chain in the future.
Mm-hmm.
So okay, so you can change the map value by some other number so that to keep track that it is visited earlier. So what you can do, you can make the have equal uh, have I is equal to okay. I have a call. Can I please pick the call?
Yeah, yeah, sure, yeah.
Hello. Yeah.
Hey.
So yeah. So you shouldn't be checking any number in the future again, right?
Mm-hmm.
So change below have by some other number. So have equal have next number equals 2. So in the while loop, you can change the have value by some other value.
Right, you're saying keep another hash map for the
No,
elements.
no, 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 no. Please check my code again
Okay,
in
yeah,
the talk.
yeah. So if
So,
to continue, J
so
while
have j equals 2 means what? I have calculated earlier, right? 1 means I haven't calculated, and 2
I
means
see.
okay. So good, good to go. Yeah, please write the code.
Um, yeah, so you just checked if have number equals 2, then
Equal to.
yeah, sorry, yeah, equals 2, and you can just continue. Um,
So
mhm.
yeah, so okay, fine. But
Um,
yeah, yeah.
uh,
But in the while loop, you should change the like in the like line 13. In the line 13,
mhm,
the next number you have like calculated the answer for next number, right?
mhm.
So that means what? It is visited. That means what? Have number equal be 2 equal 2 now. So next number have of next number equal 2.
I see. You need to change it. You need to check for each number in here as well. But yeah,
You should make
maybe you
have
could
next
just
number equal to
you can
like
just you can just do this. Is that what you're saying? You can have just have a next number and then also the same with the below number.
no, 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 no. Please see my code.
Mm-hmm.
This was okay. Like I have done up to till this position. Hmm. Okay, let me improve the code if you want. So have j equals 2.
Mm-hmm.
Okay, so uh, your code in the okay. Can you please give me a code so that I can mm, give you a, like
Yeah, hang on. I'll give it to you here.
okay, thank you so much. So so this is the interest. Okay, so let me share my screen.
Mm-hmm. I'll stop sharing mine.
Okay. Chat. Okay. So
Mm-hmm.
see. So yeah. So let's suppose you are at 4. This number is 4. Okay.
Mm-hmm.
So what you are checking is 5 is present in the map, is 6 in the present in the map, is 7 is present in the map.
Mm-hmm.
Again, you are checking if 3 is present in the map, 2 is present in the 1 in the map. Okay.
Mm-hmm.
So let's suppose all of these numbers are present in the map. So when 4, so you would, so the what would be the answer for 4? 7, right? The
Mm-hmm.
length of the chain is 7. So the next number in the array after 4, the next number would be 1. Let's suppose in the array, num array, the
Mm-hmm.
next number is 1. So do you need to check or calculate the answer for 1 again?
No, because
Yes. 1
well,
is a part of this chain, this
yeah,
chain.
yeah.
So for 1, answer is 7. For 2, answer is 7. 3, answer is 7, right?
Mm-hmm.
For every number is this chain, the answer is 7.
Mm-hmm.
Okay, fine. So that means I don't need to check this member of the chain again, right?
Mm-hmm.
So so that what I can do, I can keep some track. So so what I would be doing, I would be changing the below number, like have, so that I shouldn't check it again, like 2 or whatever, 100, okay, 1000, okay,
Mm-hmm. Mm-hmm.
whatever. So have uh what it is, no, have next number equals what, 2.
Uh, yeah. You just
And
mark
2
it saying it's
2
seen it.
means what, I have already calculated the answer.
Yeah,
That means what, I need to avoid 2.
yeah.
So if have of number, so below number is equal to, and if have number is equal to, then I would be continuing from here.
Mm-hmm.
Okay, one thing I have like forget to calculate, I should do have number equals 2. Do you got it?
Mm-hmm.
Because I'm doing it for +1 -1, but not the same value.
Yeah.
Okay, so this one. So longest max of count. Okay, fine. So let's run. So I need to log in. Sign in. So can I reserve a below number? Okay, so let's see. So below number, oh, is Neymar. Are you there?
Yeah. Uh,
Output was okay. So I haven't returned it. Okay,
mhm.
return, return, return longest. Return outside the function. Okay. Mm, okay, so answer would be initialized by count equal to 1. Okay, so here count would be 1. Okay, every time.
Mm-hmm. Uh,
So yeah,
yeah, and you don't need to check if have
so
next
it
equals
it
true
is accepted. Okay,
while loop. Okay, yeah.
so I'm providing you the code in the here. Okay, so yeah, we can end today's session.
Mm-hmm. Brilliant.
Thank you so much.
Right. Thank you. Have a good day.